Which sets of ordered pairs represent functions? We'll do number one together. You do the rest. So the first one, is this thing a function? All I have is the ordered pairs. Just check to see if every input goes with one output. 1 with 2, 2 with 3, 3 with 4, 3 with, what, 3 with, oh, look at that. The 3 repeated. It's very easy to see that the 3 goes with 4 sometimes, and the 3 goes with 5 sometimes when the 4 is not looking. So therefore, this one cannot be a function. All right. So right now, pause it, take a look at the other 3, and then let's see if you got those right. Okay, this one should have been also pretty easy for you, right? So here are your answers as they bounce in. Number 2 checks out. Every input has just one output. Number 3, it also checks out. Every input has one output. Kind of like that one on the previous exercise where every boy was going out with the same girl, and that's okay. But on number 4, it doesn't, because a boy, the number 1, has 5 different girlfriends. Goes out with himself, number 1, and then number 2, and then 3, and then 4, and then 5. So maybe Monday, Tuesday, Wednesday, Thursday, Friday, and I guess takes the weekend off. Okay, so there you go. Pretty simple. On exercise 4, this time let's look at some graphs. Which of these graphs represent functions? We're going to look at A together, and then again, just like you did before, you determine if the other ones represent functions. So I'm looking at inputs down here on the x-axis versus outputs on the y-axis. Does every input have only one thing that corresponds to it on the y-axis? And for table A, that is definitely true. So I'm going to go check. So I want you to do that for B, C, and D. And then see if you remember, or see if you can tell, is there an easier way to just look at a graph to go, ah, that's a function, or no, that's not, right? So finish those 3 problems off. All right, let's match your answers up with these answers. So if I look at graph B, I'm going to say that one's not a function. I just picked one input. I just called that the number 2. Could be whatever it is. And if I follow it up to the graph, it has an output of this one that I called maybe 3, and this one that's right up above it at 5. So my graph can't loop back on itself, because then it wouldn't be a function. Okay. C. C is also not a function, because if I say that this right here, this number, this input number is 2, sometimes it could go with the number 1 if I scooch it over, and sometimes it could go with maybe this one, which I'm saying is a 3. So you can't have any vertical parts on your graph either. That's not a function. And then finally D, if I look at the difference between C and D, it takes the vertical portion from C and then gives it a bit of a slope here. And so every input has one output. So to answer the second part of the question that's down here, what is the easy way to see if a graph is a function or not? It's what's called the vertical line test. You just trace yourself out a vertical line, and that vertical line can only touch your graph at one point at a time. Right? Anywhere you care to draw a vertical line, say, whoa, look at that, it touched it twice. If it touches it twice, this indicates that there's more than one output for that input. If this is the input, let's say that number is 3, it goes with 2 different outputs, and that can't happen. It fails the vertical line test. Same thing with anything with a vertical line that's already in it, it would fail the vertical line test. Table, our graph D, no matter where I put that line, it would pass the vertical line test. So there's the last bit of information on this objective, and that is the vertical line test. It gives us a very easy way to determine if a graph represents a function. So a relation is a function, IFF. Remember from geometry, that's a short way of saying if and only if. If and only if no vertical line intersects the graph of the relation at more than one point. So if I look at the 2 pictures of parabolas, the one that's a vertical parabola, that one's a function because of any vertical line that if I sweep it across that, it would only touch one point at a time. But the second one, the sideways parabola, it's not, because if I look at the number 2, it outputs to +2 and -2, so that one is not function. So that wraps up whether a relation is a function or not. Basically, it's every input has one output.